Hello, I'm Bill Kinney. This is video number 47 in my series on the foundations of arithmetic algebra and graphing. It's part 6 of a subseries on algebra formulas, functions, and graphing with an emphasis on spreadsheet usage. I'm going to go pretty fast in this video because I'd like to get to spreadsheets in the next video, but we'll see. Hopefully you might want to rewatch this video if I go too fast for you. Anyway, in the last video we looked still at this model of depreciation for a car that starts out at $25,000 and depreciates to $21,500 after 1 year. We wanted to estimate its value after 3 years and estimate when it would be $6,000. We found a formula for a function that modeled the value of the car as a function of time. I forgot to write down here the final answer for the value after 3 years was $14,500. That's an estimate based on this model. If the model is exactly right, then it would be exactly right, but the model probably won't be exactly right as far as a model of reality. We used it to also estimate when the value would be $6,000 by doing some algebra. Set v equal to 6,000 and solve for t, and we found that t was about 5.43 years. Ended up being 19,000 divided by 3,500, same as 19 divided by 3.5. As far as number of months, if we do this, that'll tell us it's about 5 years and 5 months. We could also find the number of days, but that's probably too much precision for this model. We're just estimating things anyway. New question in this video. Grandma lives 600 miles away. Say it's Thanksgiving and you want to go to Grandma's house for Thanksgiving. How long will it take you to get there if you travel at 65 miles an hour, at 70 miles an hour, and how fast should you go to get there at 8 hours? Of course, you know, you're not going to be on the freeway the whole time, so these really would be average speeds, but you might as well just pretend you're on the freeway the whole time. I would encourage you to stop the video and answer the questions on your own, and when we come back, and also think about it as a function situation, as we will do when you come back. Okay, are you back now? All right. Going to go ahead and use t for time. It might be good to define the variables here. T equals time in hours, and let's see, speed. I could use S for speed, though it is common to use V for speed. That's supposed to be hinting at the idea of velocity. Now, velocity and speed are not the same thing. Velocity is speed with a direction taken into account, but it is also common to use V for speed anyway. To answer the first questions, we're trying to find a time. How long will it take you to get there if you travel at certain speeds? So it's probably best if we think of t as a function of v. How do you find its formula? Well, the key thing is to use the principle that at constant speeds, distance equals rate times time, or speed times time. So therefore, time at constant speeds, constant rates, is distance divided by rate. Just divide both sides of this equation, where the variables are really words or abbreviations of words, by the rate to get the time as a function of the rate. And we use that here. The distance is 600 miles, so t is going to be 600 divided by v. And the units all work out. We're dealing with miles for distance and hours for time. And so now I can use this formula to figure out the answers to the questions. How long it's going to take you to get there when you go 65 miles an hour. Plug in 65 in for v into the formula for the function. That's what this notation means. F of 65 is 600 divided by 65. I'll go ahead and use my calculator. You can use yours. I'm not going to show it to you. It's about 9.23 as a decimal approximation, and that would be in hours. If you go 70 miles an hour, you would do 600 divided by 70, Do that in your calculator. And you get about 8.57 hours. It's for a savings of about 3/4 of an hour, a little less, about 40 to 45 minutes or something. We could figure it out exactly if we wanted to. So going 5 miles an hour faster. How fast should you go to get there in 8 hours? That was the next question. It's up here. If you want to review the questions. How fast should you go if you want to get there in 8 hours? Now we want to know the speed. How fast? So plug in t equals 8 and solve for v. I could think of this as a proportion, and you can do a cross multiplication if you like. What is cross multiplication? Well, in this case, it's just, you want to isolate v. I don't like, in a sense, the v in the denominator there. I could multiply both sides by v so that they divide out on that side, and I get 8v equals 600 times 1. That's equivalent to the cross multiplication idea in this case. And then you can divide both sides of that equation by 8. 600 divided by 8 is 75. So you'd have to go 75 miles an hour in order to get there in 8 hours. I also could have solved that problem by doing this in general. I could have found a different function back up at the top, v equals g of t, by solving this arbitrary general equation for v in terms of t, and it would be 600 divided by t, which is the same thing that I did down here. G is called the inverse function of f, but I don't want to focus on that. Let's graph this and just get a broader picture of what's going on here. The graph is going to show you everything at once. That's another benefit of graphs. Keep track of my colors here. T is time in hours. We're going to solve, think of the first function where v is the independent variable. I think I'll use centimeters now on the horizontal axis. And I guess I'll pretend these are all in units of 10 miles per hour. I've got 5 of them. Not doing this super accurately because I'm going quickly. This is v, miles per hour. Speed in miles per hour, 10, 20, 30, 40, 50, 60, etc. And then this would be time in hours. Maybe use units of half centimeters. 1, 2, 3, 5, 6, 7, 8, 9, 10. 11, 12. Not going to take time to write all those out. The function, again, was t equals f of v equals 600 over v. Plug in points. You can make a table and plug in points. When, for example, when v equals 10, 600 divided by 10 is 60. We don't want to go at 10 miles an hour. That's way up here off the scale. V equals 20, 600 divided by 20 is 30. That's also off the scale. 600 divided by 30 is 20. You're getting close. 600 divided by 40 is 15. It'll be up here somewhere. 600 divided by 50, that would be 12. I should have made my vertical scale differently here, but 600 divided by 60, that's 10. Doing this quickly. 600 divided by 70. Oops. You already did that. 8.57, 10, right around here. And it's good to graph more of this because this actually turns out to not be a straight line. They almost look like they're on a straight line, but they're actually not. If you plotted more points, you'd see it's not. You'd see it's actually a curve. That looks about like that. It's an example of something called a nonlinear relationship. This formula is called an inverse proportionality. The amount of time it takes you is inversely proportional to the speed that you go at. By the way, you also could have written this in this notation as 600 times v to the negative 1 power, where it's just the v that's being raised to the negative 1 power. That's called an inverse proportionality, and inverse proportionalities have graphs that are not straight lines, and they're often that kind of shape. Well, they are that kind of shape when you have a positive number in front of the independent variable being raised to the negative 1 power. And then you can use the graph to answer more questions and to see the overall relationship. The faster you go, the shorter amount of time it's going to take you. This is a decreasing function. However, even if you went, super fast, thousands of miles an hour, like you're in a supersonic jet or something, you're still not going to get there in 0 time. This graph is not going to go down to 0, though it's going to get arbitrarily close to 0 as v increases. That's kind of an interesting thing to think about.